fair enough. Well, we can start with a presentation from ourselves. This is Raquel. I'm working as software developer, but mainly as front-end developer in Tinybird. And I live in Alicante, and it's a sunny place in Spain. And yeah, more or less, this is me.
Yeah, I'm Alberto, and I do the backend. So I'm gonna complement Raquel in this coding session. I live in Valencia, very close to her. And
Yep, really good.
bear in mind, we are developers, and today we're gonna be users. So let's see
Yeah,
what
that's right.
happens. That's not our expertise, but I mean, we try to do it fun
Yeah.
and see what happens.
Yeah.
So we're gonna do
Yeah, we're gonna start with some explanation about what's AirPlace. For those that doesn't know what it is, it's like it was born in 2017 on April Fool's Day, and it was repeated again this year on 2022. And it was like a collaborative project and a social experiment that was hosted in the social networking of Reddit. And there was like an online canvas where every user could change the color of a pixel, but only one pixel, because I mean, when you changed the color of a pixel, you had to wait between 5 and 20 minutes to ingest another pixel. And yeah, that was mainly what it was. And it was in April Fool's this year. And we have been analyzing the data generated in this last event this year using Tinybird, and Alberto has found some fun facts to highlight. And if you want to share with us what you have found.
I found out that they shared all the user generated data. So what I did was load it into Tinybird, and I found like several fun things or interesting things. Also, it helps to understand the impact that this event had and some challenges they had to face. So, for instance, this is the distribution of pixels that users draw during the event, during the 4 days. I mean, you can see there were like a spike or a peak of almost 6 million pixels per hour. This event had a lot of impact in streaming platforms and so on, and you can see there's some correlation. And the peaks were more or less at midnight when European streamers were mobilizing their viewers. And one interesting thing is if you aggregate the data by second, I mean, you can see there are spikes of 8,000 people concurrently trying to draw pixels. I mean, this is not a toy project at all. This is quite a huge challenge. And taking into account, this is just the part of ingesting data, but at the same time, you have to refresh the canvas and so on. So this is a pretty nice use case for a real-time platform like ours. And I did a little bit more of research. So for instance, it's very easy to see that users generated 160 million events. There were 4,000 pixels no one clicked on during the all event, so they were left blank somehow. There were people cheating or doing like weird stuff, so they had to build like an eraser tool. So instead of having like, you see that every coordinate has a color and a timestamp, there are some records with 4 coordinates, so they have to build a tool to draw a box and cover up certain areas. I mean, with offending parts, or I don't know. Also, there was some controversial thing about communities using bots. I mean, I cannot assure, but it's very weird. One single user having been almost 3 days clicking nonstop on the canvas. I mean, I don't know.
It's weird. People with not a lot of things to do.
Yeah. Taking into account there was a limit of 1 pixel every 5 minutes. So
yeah, you have to be
someone, no human, was like 3 days clicking on the canvas. And there was one thing that it's very nice to see. I mean, I did a spatial aggregation, and if we visualize the areas where more activity had during the event, this one place in here in the bottom left side of the canvas. I mean, this was a total battlefield between Spanish and
With
French.
French
Yeah, I
people,
mean,
yeah.
they came crazy. They tried to take down each other drawings. I mean, you can clearly see it here. I mean, there was most of the activity was in here, especially in the last day. And there was another interesting thing is that the event ended with what they called a whiteout. Basically, in the last hours of the event, they left only one color to draw. And you can see a huge spike at the end of white color. So this is how the event ended. And what we were going to try to do is to bring this to life again. Okay.
Yeah. Yeah, we're gonna try to build a really simple script to create our own canvas and to print pixels in the canvas. Then we are gonna ingest this pixel in our service, in our backend, that is Tinybird. And then we are gonna get the initial state of the canvas to see all the pixels that we are ingesting, to see this pixel in our canvas as an initial state. Then we are gonna try to refresh this canvas with the pixels that other users are ingesting in real time. And as the last thing, we're gonna try to recreate the airplace canvas in our canvas, and to go to a snapshot of this canvas in the past, and show it in our own canvas. And then to finish, we're gonna share the canvas to you to draw together in real time.
Yeah, that's it. We've started a repo with everything. I mean, it has instructions. I guess it's easy to start. But we're gonna do it everything live in Tinybird directly in the UI. So I'm gonna jump directly into my account. This is Tinybird, and I'm gonna create a new empty workspace. I'm gonna call it workplace live. And I'm gonna add Raquel.
Yeah, that's me.
As a member of this workspace, because we're gonna work together. I'm gonna work in the backend. Raquel will work in the front-end side, so you'll see how we both work together on this project. Mm-hmm. And first thing we're gonna do is to define the schema of the data we're gonna do. We're gonna ingest, users are gonna send. And for that, instead of creating a new data source, thinking on the schema and the data types and so on, I'm gonna create a sample JSON file. So we're gonna need two coordinates, an X and a Y coordinate. We're gonna need a color. For simplicity, we're gonna use, I guess it's fine using hexadecimal, right? I think we can use hexadecimal right away. And we're gonna use a date because multiple users can draw in the same pixel, so we need a timestamp so we can jump in time.
Yeah, to get the last pixel.
That's it. I'm gonna put June today, 0, for instance. Gonna put a couple of more pixels, and I think that's fine. I'm gonna save it. Pixels table, for instance, JSON. I'm gonna save it here. And once I have it, I'm just gonna drop it into my dashboard. This is I mean, very common way to start a project. you have some data, you drag it into Tinybird. And maybe if I write, well,
then the JSON.
we're missing anything.
I think it's the space, this yellow space that it's weird. Yeah, I think it's
I don't
that.
know what I did.
Yeah.
Wait. I'm gonna clear. I'm gonna start again. So
yeah.
When you drag any file, what first thing you have here is a preview, and we have guessed the columns, the types, everything is right. I mean, date is a datetime, the color is a string, the coordinates are an integer with a nice precision. We could use unsigned integer, for instance, but I mean, let's move on with this. So let's create a data source. So now we're going to move to the front-end side. And we're going to try to put data, user-generated data, in this data source. How this works in Tinybird. In Tinybird, a data source is kind of a table with steroids. I mean, you have many operations. You can do a feed. One of those actions you can do, one of those operations is appending data. We have a very nice API to do it. And you'll see now how Raquel integrates this part. But first thing we need to do is to create an authentication token with right permissions on this data source. Okay. So let's create the token. We'll be using this token during all streaming. Let's call it replace. Let's give permissions to the pixels table for appending new data. We save it, and then we can jump. Cameron, can you switch to the Raquel?
To my screen. Yeah, we're gonna change. I think we have here the token that Alberto has shared with us. And to start with the front-end script, we're gonna create a really simple script with a canvas. We have here in the HTML a canvas that is gonna be our canvas. Then here we have some inputs to change the color. Then we have a date input to put a date in the past to something that we are gonna do later to represent the canvas in the past. But by now we're gonna start with the canvas that we have defined. So to start, we have to define the measures of the canvas. We're gonna create an init function. We're gonna create an init function, setting the width and the height to the canvas, and with this canvas that we have created here, we have to call the function. With this canvas that we have created here, I have to define the canvas first. Coding in live, it's like a mess. Well, now we have the canvas with the width and the height, and we're gonna try to implement the pixel drawing in the canvas, just with calling the canvas dot mouse down or mouse down event. We're gonna call a function called, for example, use brush. And in this function, we're gonna get the pixel that is clicked in the canvas, and then draw this canvas in this pixel in the canvas. Well, let me copy the function that it's gonna be used to get the pixel clicked. We're gonna get in the position of the mouse in the canvas, and calculating the position in the canvas, and then setting the color that we are gonna select in the input of the color picket that I have to talk later. before, sorry, this input, we're gonna get the value of the color selected in this input, and we are gonna create like an object with the position X, position Y, and the color of this pixel. With this pixel, this object pixel, we're gonna draw this pixel on the canvas. To do it, it's really simple too. We're gonna create a draw function that is gonna create like a rectangle in this coordinate, the X and Y coordinate, and we're gonna set the color of the pixel in the context of the canvas. So yeah, we're gonna get the pixel clicked, then draw the pixel in the canvas. It's really simple. And if everything goes well, we should see, yeah, here the pixels that are gonna be created in the canvas. And then to ingest this in the backend in Tinybird in our data source that we have created, we're gonna call an ingest function, ingest pixel function, for example, that is gonna do a post to a Tinybird endpoint that has to have this structure. We have the base URL that is, I'm gonna define it. It is api.tinybird.co, and then with dash v0 dash event, and then the name of the data source that we are gonna ingest on. We can ingest it, the pixel. We are missing the token that Alrocal has created. We're gonna add it in a environmental variable that will be added to the post call. I'm gonna copy this is the token and define it here. I had the old token, sorry. So yeah, we have the ingest pixel. We have the function that is doing a post message, a post event to our data source with the token that we have created. So if everything is okay, we should see here in our network calls to our API endpoint with no pixel. No, I have to send the pixel. We are ingesting nothing. Let's try again. Event. Yeah, it seems like no, it's not okay.
Quarantine.
Okay, we are missing the date column. Yeah.
Okay, wait a second. Can you share the quarantine, because I think it's pretty interesting. So once you send an incorrect file format or body format, in this case we were missing the date column. I mean, you have some ID in here in the data source. You have like a quarantine table attached to every data source. I mean, so if something goes wrong, you can go here and fix your ingestion process. This is very, very, very common especially in development.
Yeah, as it has happened to me. Yeah, so we have to add the date column to tell when the pixel has been created. So to do it, I have created a really simple function to try to not add any extra library, calculating the actual moment in the specific format that we expect in our Tinybird data source.
It's ISO format, I guess.
Yeah, it's ISO. That is year, month, day, hour, minutes, and seconds. So yeah, we have created an object with the date of now, and then we have extracted the day, the month, the year, the hour, the minutes, the seconds, and to collect the date as this. So let's call this function here to add the date of this moment. So now everything should be working. Let's see.
Yes, I can see.
Successful row.
Some
Yeah,
events
we have it.
already. Okay.
Yeah, we have it. So we can switch to Alberto, because the next step, because we are ingesting pixels, but if we refresh the window, we are losing everything that we have created.
Yeah.
So we have to fetch the initial state of the canvas with every pixel that we have in the data source to print it in the canvas.
Yeah, we're gonna build an API endpoint, which is one of our core features. And you're gonna see it's quite simple. In this case, we have the pixel stable data source, and I'm gonna create a new pipe in which I can write SQL to perform the analysis we want. In this case, I'm gonna call this pipe as get snapshot. And what I'm gonna do, what we need to do is to write a query which is called point-in-time queries. Basically, we're gonna have like time series, and we're gonna have different values, different colors for the same pixels, but we just want the last color for each pixel because we want like the snapshot state, the current state. So we're gonna do is we're gonna select the X and Y coordinates, and we have a function which is called argmax, which is gonna give us the color for the maximum date. Then if we group by X and Y, you can see, for instance, the pixel 00 has different events for the white color, one at 0 seconds, 1 and 2 seconds. And I print the date.
I think it's the comma. Yeah.
I mean, the function is doing what we want, which is basically taking the last colored pixel. Now, once we have the API, the analysis, the SQL, in this case, it's very simple. We can create a REST API based on this. We just have to click on that button, and we automatically have a URL we can query from anywhere. I mean, in this case, we're going to integrate it in the front-end side. As you can see, it automatically has an authorization token, and we're going to have an array with different pixels and their color. I'm going to call this color. And for convenience, so we're going to have an X and a Y and a color. And since we are using an already created token, I'm going to give read permissions to this pipe. I'm going to save the token. And now it's time for Raquel to integrate the API.
Okay, so yeah, we have just to fetch to this API endpoint and print the pixels that this call results. So we're gonna add the init function that we have created here. We're gonna add a function called, for example, print snapshot.
Hey, Cameron, can you switch to Raquel?
Oh, sorry.
Screen? Yeah, cool. Thanks.
Okay. Yeah. So here in our init function, we're gonna create a snapshot, print a snapshot function that is gonna fetch the canvas. Oh, fuck. This is for later. We're gonna fetch to this API endpoint that Alberto has created, and using a get. And with the data that we are gonna receive, we're gonna iterate in this data and draw in the canvas with our function draw that is here. I'm gonna put it here at the beginning. We're gonna call this function draw with the object that is gonna have an X and a Y and a color parameter. So yeah, if everything is okay, if we refresh here, we are seeing here now the pixels that we are in this. I'm gonna put a lot of here to see, and if we refresh, we are seeing now the pixels that we have been ingested in the past. So yeah, but to make it work in a real time and in a collaborative way, we are gonna try to fetch I don't know, every 3 seconds to the last pixels that has been ingested. With this, we are gonna try to print the pixels that other users are ingesting in at the same time as us. So to have this, to not get all the pixels every time, we can maybe add a parameter to get only the last pixels ingested in the last 10 seconds, for example.
Yeah.
So yeah, I think you can change the API endpoint to add.
Let's switch
to
my screen. Because I mean, it's not convenient having to load again and again the whole canvas to get others updates.
Yeah.
So I mean, a convenient way is to just do polling. So can you switch to my screen, Cameron? So in the same pipe we had before, we're gonna add a parameter because we want Raquel to send a date, so we can filter the SQL. I always use these snippets because it's very easy to forget about this syntax. This is a classical Python templating syntax. And what I'm going to do is only when I get a param call in the request called start date, instead of getting or scanning the whole table, I'm going to scan the rows whose date is bigger than the date we received as a parameter.
Mm-hmm.
What a brief description, because this can serve as documentation. I'm gonna put the format. To filter the snapshots and do polling. And that's it. We've added a parameter, and this is really, I mean, the parameter is available, so you just have to use it.
Yeah.
So let's go back to front.
Okay, if you change the screen, Cameron. Okay, so now we have to use this parameter and call this fetch every, I don't know, every 3 seconds. So to do it, we are gonna create an interval that is gonna call a function every, for example, every 3 seconds. And this function should fetch to this API endpoint. So I think we can use this function too, but modifying it, adding some parameter. For example, if we add here the date start parameter, the date start parameter, that here we receive this parameter, and we have to add it to the function, to the API endpoint call. So if we receive the date start parameter, just create date start param.
I call it start date.
Sorry.
Oh, yeah.
Start date. Okay. And if we don't receive it, just nothing. And we will add it to the endpoint. So as this function is being called here too, to not make it broke, we're gonna add this as by default. Okay. And now, yeah, here we have to send the date of now, but 10 seconds ago, for example, to fetch the pixels that has been ingested in this 10 last seconds. Okay. So to do it, we can use the function that we have created, because we have to send the the date in the same format. But I think we can add another parameter, for example, the milliseconds that we have to subtract to the date here, and just subtract these milliseconds to the date that we are generating, the date of now, subtracting the 10 seconds. So yeah, but this function is called here too. So we are gonna set this to 0 by default. So if everything is okay, we should be here. Okay, here. Every 3 seconds, we are seeing a call to our endpoint with the data, the start date, and we are receiving the pixels that have been ingested. If we add pixels, we're gonna see our own pixels too, because as we are done filtering by user or something, we will see our own pixels at the same time.
Perfect.
So yeah, I think that's all. And we can add the function of asking a snapshot in the past to check how the canvas looks in the past.
Okay.
So if you switch to Alberto screen, because we need to add another parameter to the endpoint to make it possible, I think.
We have now like the live version. Okay, so once we publish this, we can join to the website. We'll do it in a few minutes, and we can start draw collaboratively, and everything will be updated at the same time and so on. But we thought it would be cool to now that we have the data that was generated in April, we're gonna modify this endpoint so we can go anytime in the past and see what was the canvas like at that moment. So I have a pre-created workspace in which I loaded the historical data. Okay, this is the data that was produced in April in the actual R place. So what I'm going to do is to share this data source to the other workspace so I can work with it from there. And this is like a very common way to work as well. It is very common that teams that work in Tinybird have like a workspace with a source of truth where they ingest all their data, and different teams share parts of those data sources to build their analytics. Okay, so this is like a way of doing it. Now that I have access from the workspace we were working on to this historic, I'm going to modify this pipe, which is the one we have published as an API, to take data from this other data source. So I'm going to create a different, first of all, I'm going to copy this. And I'm going to change this table by the historic, taking into account that the schema is different. So I have to change several things. For instance, coordinate is a string, so I'm going to transform it.
Yeah.
I'm going to transform it. I'm going to split the comma, the coordinate. First is the x, second is y, and this is an integer. Same here. So now we have the x and y. Date is not called date, but it's called timestamp. Pixel color is not called color, but pixel color. And I'm going to use a different parameter. So when Raquel sends, for instance, historic date in the URL for this API endpoint, I'm gonna filter this node by that parameter. But in this case, we're gonna get all pixels, the last colors for each pixel until that time, okay? And wait, I'm gonna change this, use this to go any point in time. And I think this should work. What I'm missing,
yeah, it's timestamp, not date, right?
Sorry, this was a comma.
Okay.
I don't know why I put an M.
Okay.
Okay, now we have it.
Okay.
And now I'm gonna do this. So if I get the historic date, I'm gonna select from the historic. I'm gonna call this historic. Select from historic. And if I don't get any parameter, I'm gonna select from, I'm gonna call this snapshot. From snapshot. If we go to the API, we have, we should have both parameters available. Let me check again. Historic date.
You have to change the node, no?
Right. So we have published the first node, and now we have to publish this one because when Raquel does a request to this API endpoint, we want to execute this logic, okay? So I'm gonna publish this one. Now in the API, we have both parameters available, and we can integrate in the frontend.
Okay, so that's my turn. So yeah, we have here the like a data picker input. So once it is clicked, we're gonna add some logic to first to stop the real-time function that is gonna stop the interval, because we don't wanna be reversing the canvas anymore, because we just want an image of the canvas in the past. So we are gonna set the real time to false and set it to true by default. So yeah, this is gonna stop the refreshing function. Then we need to clean the canvas, because we need a blank canvas to print the snapshot in the past. So we are gonna use this function clear rect and clean at the beginning and at the end to the canvas, to the beginning to the end. And then we are gonna get the date that is gonna be selected in the input. It's selected. Wait. That picker that we have defined here, and we are gonna get his value. And then we are gonna call the same function that is calling this API endpoint, but with another parameter, with a parameter historic date that has alrocar defined. So here we are gonna check if this parameter is, if this parameter is added, we are gonna add another parameter with historic date and give the value of this parameter. And if not, we're gonna check if the data start has value to add this other parameter. So here we need to call the same function, the function print snapshot, that is gonna call the API endpoint and then draw in the canvas the pixels collected. But with the parameter historic date, with the the date selected in the input. But I think this is not gonna work because the input, the input collects the date in another format. But let's check if we get,
Okay.
Yeah.
When
the date it's in this format, so we have to convert this in our format, that is just adding, for example, a replace. We have to replace this, well, the t that was in the middle of the date and in the hour with an space, and then as this input is just collecting hour and minute, we need to add the seconds concat with a concat function. We'll add just 00 by default, because we don't need so much precision for now. So with this, it should be working. So if we ask to date when AirPlace was happened, that was in April. If we check here, it's not working. Date will processing.
What is that? It's my fault. Wait a minute.
Okay.
Try again.
Live stuff. Again? Okay.
Yeah, it's because
here, yeah, it's working.
Yeah,
it's working now.
Okay.
Here we have the canvas of AirPlace in that date.
We could reproduce any point in time. I mean, that's pretty cool.
Yeah.
Of course, there are many things we could do, I guess, to optimize.
Yeah, because the render is slow. Yeah.
I guess both, but I mean, it's pretty cool to go and see what happened.
Yeah. Yeah. So more or less, that's all.
Yeah, I think
we have
really
published. Yeah, we have published this application that it's more or less that we have done. So you can play with it, adding some. We have added some functionalities. For example, you can draw a line, not just a pixel. This is if we check the network, this works with a single API endpoint call with a single post, but with the format of JSON.
The events API is very convenient for sending one event or for sending like an array of events. And in this
we
case,
just have to add it here, like an JSON that it's an object in a JSON and intro. I don't know, another line, and with the other object.
Yeah.
So yeah, that's
pretty much it. I mean, we wanted to leave some time at the end, in case if you had questions, or in case if you wanted to play around, or I don't know. I'm gonna take a look at
the chat.
Yeah, we have. We were preventive, and we built like an eraser tool. So be aware. If you see something weird, it might be magically erased. But anyway, just play and have fun. The nice thing about this is, think about what we've built. We've worked together. Raquel has been doing all the front-end side. I've been doing the back-end side, but I haven't written any line of code. And we have APIs for sending data. It scales. By default, it supports 1,000 events per second. But I mean, we have customers that go way beyond that, and they don't have to change anything. It's the same API. It's all on us. And we've created an API to update the canvas. We have two versions. We have the real-time version, so you get the last snapshot, but we have like the heavy one, like going to the past, to the 160 million rows data source, and bring the thing out. So this was what we're going.
For my point of view, that I'm front end, it's like magic. to create an application with the backend, like with nothing more or less to do. So yeah, it's like an amazing having an endpoint ready in seconds and being able to create my front-end application with not a lot of effort. It's really nice.
Cool. Hey, let's draw something. Okay, so I mean, we have we shared in the we'll share in the chat or in the follow-up email or whatever. We have the GitHub repo with everything. This is like super straightforward. We didn't mention, but we have a command line tool. So basically, you can build all this stuff with a couple of commands in your terminal. Can you share my screen a little bit? Oh, no, don't share it. I didn't see that. Well, we have our Slack community. You can join and you can ask whatever you want. That's it. Hope you like it. This Tinybird logo. I mean, what's that?
It was me. The black one, it was me trying to do it, but
I mean the green one. My avatar. Who is this? Is me or is it Jordi?
Who knows?
Cool. I mean, I like
some bots creating stuff in the canvas, I think. Okay, so that's pretty much.